Yeah, thanks everyone who joined, and thanks for Subsurface for the invite to give this talk. As Tony mentioned, my name is Sihan. I'm a software engineer at Apple. I work on mostly open source Apache Iceberg on the same team as Anton and Russell, who's also in this talk. Before Apple, I was working in other companies like Informatica, Cloudera, and Criteo. In the Apache world, I'm a committer in Iceberg, but before this, I worked many years on Apache Hive. I'm a committer in PMC there, so I have more experience in Hive, but lately I've been really interested in Apache Iceberg. So yeah, I think let's just get started. So first, quick brief overview about Apache Iceberg. I think there's already a lot of talks in Subsurface about Iceberg. I heard some really good ones from Anton and Ryan. So the core concept, Iceberg is a table format. It's a way to lay out files in a table. It's a specification, really. I would say the very core building block of Iceberg is the metadata file. This essentially is just metadata of other files. They could be other metadata files, but eventually you want to be metadata about data files. And what we track is just basic stuff. For example, membership, like what data files belong to the table, what data files belong to different partitions within a table. But aside from that, Iceberg has built like many more features on the metadata file. I think some previous talks mentioned before, we keep column statistics in our metadata files. So for each data file, we track a lot of column stats to help us prune away entire files during query planning time, which leads to really nice query performance if the table is structured correctly. And then I think there's some talks as well about snapshots. That idea is just basically, again, based on metadata files, we kind of keep around the old ones every time we update the table. Those are kind of now called snapshots. And with that, we can implement features like time travel, which maybe you know, where we can kind of use those old snapshots to explore the table at those points in time. And I think from the previous talk, tagging and branching is built on top of that as well. So a ton of features in Iceberg built around metadata files. I mean, it's all built on metadata files. That's the only physical manifestation really of Iceberg. Many more that I didn't have time to list, but today's talk is about metadata tables. So metadata tables is just a way for me and you as users to get exposed to the metadata file, and we can leverage all the raw metadata that Iceberg has. It's exposed to us in the form of SQL, like system tables. We can query it using SQL just as easy as we query the data tables. And I would even go so far as to say, if you can answer a question using metadata tables, you should do so rather than data tables, just because querying the metadata files is going to be much faster than the querying the data files, just given the size. So to me, this is why I think it's really Apache Iceberg's best secret. It's kind of like an underutilized feature, but it really kind of makes Iceberg just totally open and transparent as a table format. Users and increasingly tools are using metadata tables to see like under the hood how the system works, and they can have a chance to improve it. So my talk is trying to be more user, kind of solving user commonly asked questions. So I'll try to go over like first how to use metadata tables to answer most problems you may have about Iceberg. Secondly, how systems can use the metadata tables to, preemptively optimize the table and prevent performance problems down the line. And finally, if I have time, I even want to show how we can use metadata tables to kind of go beyond what Iceberg has, like using Iceberg's own metadata to build systems beyond what Iceberg itself provides, like, for example, data monitoring, auditing, and quality. So I think, yeah, with that, I'm just going to go straight to the first example. Yeah. So my first metadata table, and this is my own first one, but I think also a lot of users, first-time users of Iceberg may hit this as well. So coming from Hive World, I remember the very first query that I tried on Iceberg Spark was a show partitions, just out of habit. And if you ever try that in Iceberg, you will know that this is not supported even today. So I remember being kind of super confused, as Iceberg obviously supports the concept of partitions. So I asked on our internal Slack channel, and then I remember getting the answer saying, "Oh, we support it, but it's in actually via the metadata table form." So instead of the querying the data table where you query db.table, you do db.table. The keyword partitions, and the partitions is going to be the type of metadata table. And I remember trying that. And immediately I was really impressed by how user-friendly this whole experience was compared to Hive. In Hive, the show partitions was always kind of a one-off, strange Hive-specific statement, whereas now with SQL, it's much more natural. Like you can do cool things like what I'm doing here. You can kind of like order by, like sorting it. You can join this with maybe other even data tables. So SQL brings a lot of power. And then secondly, I really like the fact that this table also had additional columns. So in Hive, it returned only the partition values, but here we're returning other things like record count and file count, which I think was super useful, like to have when you're interested in partitions. So this is actually how I got like kind of very interested in Iceberg and started digging myself deeper into it. As I dug into like how partitions table was implemented, I realized that it was actually just an aggregate view of an even like richer table called the files table. And as I dug deeper, I think I realized Iceberg just has like so many metadata tables with very rich metadata that I think a lot of users may not even really know about. So hence my talk. I think Anton's list this morning said there was like 16. So this list is ever increasing. The community has added many metadata tables and is adding more as we speak. So I would encourage everyone to come back from time to time to see what new cool things metadata tables will offer. So for today's talk, obviously with 30 minutes, I don't have time to go over like every single metadata table. So I think I'm just gonna, in a broad stroke, try to group, tell you like in the broad categories, which ones refer to which. So to me, it was always very helpful to have this metadata diagram of Iceberg kind of in the back. To me, actually, metadata tables was a great tool to even learn Iceberg, as I can, visualize the metadata files in my own table. But essentially, Iceberg's metadata files is kind of hierarchical. That's the main takeaway of this slide. On the top, so skipping the catalog for a moment, which isn't metadata file, at the top, we have this root metadata file that has children, which are the snapshot files, that has the children, which are the manifest files, and then it has the children, which are the data files. So kind of an easy hierarchical structure. Each metadata table corresponds to one type of this metadata file in this hierarchy. So like the latest table, I think, is metadata logs, or one of the later tables, and that it will give information about the root metadata file. If you want information about the snapshot files, you will go to snapshots history. That will give you kind of like, how there's these snapshot pointers I was talking about, where you can kind of go back in time and do time travel. Underneath, then you have the manifest table that talk about manifest files, and then you have a whole bunch of other tables talking about the data files. I guess the question, is why we have so many tables if there's only this many layers. So it's actually for convenience, just to talk about the data files. A lot of users, when they use Iceberg, they're more interested initially how Iceberg lays out their data, right? They may not necessarily know enough in the beginning to care about Iceberg's own metadata. And even in there, we have kind of like views that are more for simple use cases, and then views that are more for advanced use cases. So the best example, again, is the partitions table that I mentioned, like my first metadata table. Even though, partition is actually kept on each data file, right? Each data file has an annotation which partition it belongs to. We don't necessarily want the user to have to query the files table to get the list of partitions, right? The very first time users. So hence we have a partitions table, which is kind of like pre-aggregated view for the users. And then if they want the more complete view, they will have the files table, which has, partition information of each file plus other attributes, physical attributes. For example, like the file size, file length, same thing, file path, file content, things like that. And if you want even like every single metadata we have on every data file, that's going to be the entries table, which is kind of hidden. It's more for advanced users, but that has even things like the snapshot ID of which made the file and things like that, kind of context information, which I'll try to go over some examples later. And the other dimension I'll talk about is we have this all underscore tables, like you may see in the list, all files, all manifest, and then just files, just manifest. So the point here is like, if you just do without the all, that's going to be the metadata files of the current snapshot. But if you do all, then you get like, as the name implies, the metadata files across all snapshots of that one type of that one layer. And then there's also a third dimension, which I won't have time to talk about, data and delete files, These tables I think I added at the end of last year. Essentially, you may have heard Iceberg v2 merge on read has this concept with delete files, which are kind of like negative data files in a way. And these are just views for that, but I don't have time in today's talk to talk about it. So apologize, that was kind of like a big whirlwind tour of like, because given we have so many metadata tables in the short time of the talk. So I think the best way to wrap your head is just to, I'm going to try to go over examples of commonly asked questions and see how we can use metadata tables to answer these questions. So start off with partition questions. And these are actually questions I think came up on the Iceberg dev list, and some users as well has asked me this. So common questions about partitions is like how many files you have per partition, what's the total file size of each partition, and what's the last update time per partition. So let's just go over one by one. How many files per partition? Like how would you answer that using the metadata table? So if you remember from my first metadata table, like the partitions table, that was easy. It's just, it already has a field called file count. And so the answer here is just, you just select that table and that field, and you get the answer, how many files per partition. For the total size of each partition, this is a good example where the partitions table in Iceberg, we don't have this field pre-aggregated for the user. It's pretty easy to implement, but we just don't have it at the moment. So here's how a user would be able to just use the underlying files table to get the answer, to do the aggregation themselves. So each file, again, has a partition annotation. So you kind of just group files by partition. Now you have different groups of files. And for each group, I'm just summing up the file size in bytes. So that's going to be the total file size per partition. Still kind of easy to understand. The last query on this slide is kind of the biggest one. And it looks complex, but I promise you this is kind of like probably the most complex one in this slide deck. So, so the idea here is that underneath files, there's like a bigger thing called the entries table, which has even more information. And there it has information about Snapshot, like which Snapshot added this file. Because files update time, in Iceberg, a file is not actually considered added to a table until it's part of a snapshot. So we actually have to join the entries table with snapshot table to find the file's commit time, because that's going to be the same for all the files in that snapshot. So that's what we're doing here. We're joining entries with the snapshots table, but and then we're doing the same thing. We're grouping by the partitions. So for each partition group, we go through and find the maximum snapshot commit time, and that translates really to the last update time per partition. I would say if you kind of like understand this query, you're already like expert in the Iceberg metadata tables and can answer pretty much any question someone throws at you about files and partitions. I will explain a little bit this last query a little bit. So the concept of snapshots also sometimes, a snapshot ID also sometimes confuse the users. I think I've gotten this question because snapshots, in Iceberg typically refer to a state of a table at some point in time, like snapshot example. Snapshot foo points to like 10,000 files. But snapshot is sometimes also referred to an operation on the Iceberg table. For example, snapshot foo has added like 5 files that weren't part of the previous snapshot. And that's really what we track in the entries for each data file. We track like what snapshot has added it and what snapshot has deleted it. Because if you think about it, file's life in the Iceberg table, it's added once, and then it goes through many snapshots where it doesn't touch it, and then it gets deleted once. So the point here is that entry snapshot ID tracks which snapshot added and deleted it, and then the status will be what's the operation. And so to kind of illustrate that, to ground that a little bit, I will pose 2 questions that kind of look similar but are slightly different. First is what files have been added by snapshot foo. So the answer to this is just previous slide. Entries table has a snapshot ID. So you just query all the entries with snapshot foo, and then status equal 1, meaning added by snapshot foo. So that's pretty easy. Status equal 2 obviously will be deleted, but what files were deleted by snapshot foo. And then the second one, what files are referenced by snapshot foo. Again, this will be much bigger list than the first one. So this one we'll be using, instead of that entries table, we'll actually be using the time travel. So this is, if you know time travel, like this is the exact same syntax I think Iceberg uses for data time travel. And I'm just showing you can do the same thing with metadata time travel. So keep that in mind. You can select from files table version as of foo, and then get all the files as of time foo. I think that's sometimes helpful to do snapshot analysis. So next is of how, so that's like commonly asked questions. Now I'm going to talk about how systems can use Iceberg or metadata tables to know when to optimize or maintain Iceberg tables. I think there's already, again, like talks in this subsurface about table maintenance operations. This is going to be more at like the which metadata tables to use level. The common one is Expire snapshots. I mean, obviously, it's great that Iceberg keeps the old data around for time travel purposes, but they do come at the cost of disk usage, right? So often you'll have customers or users, like first-time users, like deleting data, compacting data, but still not seeing the disk usage decrease. So the tables I like to query in this situation is going to be those all underscore tables that I talked about a few slides back. And then compare that with the non-all versions, the current snapshot versions. So these is actually some queries I like to graph in my own like dashboard, like periodically, just to visualize it. You can just query like the file size of all files and all manifests, compare with the files and manifests. And if the former like is much greater than the latter, that means that you have a lot of data stuck in old snapshots and not necessarily the current snapshot. So you're actually going to gain a lot by expiring snapshots in this case. Another good operation to do from time to time is optimizing metadata. So this will really help the query planning time, and even one thing is it will even help the runtime of metadata table queries themselves, right? It's like maybe if you have a show partitions query taking a long time, you would want to do this operation. So the key table in this scenario to know when to execute this is the manifest table. Basically, the simplest way is just to get a count of the manifest files. If you have as many manifests as you have data files and something is quite wrong, you don't want too many small manifest files. You actually want each manifest to have like kind of like maybe 1,000, 10,000, or some kind of like big number of data files that it points to. That way you get kind of a balanced hierarchical tree. You can even in the manifest table like graph out for each manifest how many files they point to see like is there a point in time where something went wrong. And for very advanced users, you can even do like sorting of manifest files. And so what does that mean, sorting manifest files? So each manifest again points to like maybe a lot of data files, and each of those data files have partitions. So you could actually sort the manifest files so that each has kind of like a discrete bounds of the partitions. And that way, when you get like pruning in partition pruning, you can prune away entire trees, subtrees quite easily. This is kind of more of an advanced technique, I would say. Optimizing data. So this is also very important, obviously, for query performance. Small file problem has been the bane of query performance for forever, right? Just due to the overhead it takes to open each file. Your friend here is the files table. So similar to the manifest table, the best way is just to get a count of files and the size. And I think files table, you can actually group by the partitions. And what I'm doing here is I'm getting the file count, which is just the count star, and then the average size, which is just, again, the total size in bytes divided by the count star. And so, if you see your files each has only a few kilobytes, then that's really too small. And that's going to be a really bad query to run on that table. You want to have bigger, maybe something bigger than HDFS block size, some tried and true values, things like that. And then the next one is like you can optimize the data files as well by sorting them. This is a column I added very recently, readable metrics column. I think it's quite useful. Like in my previous talk on this subject, before this was available, it was kind of returning a byte array, which was not very parsable. With readable metrics, we can actually now drill down on each column and then get things like lower bound and upper bound that for the metrics we have for that data file, and then that will come as that type of that column. So in my example, I have a string column, and now I can visualize for each data file lower and upper bounds, and again see if I have the data files sorted, right? Like they have discrete lower and upper bounds. If they do, then obviously when you have a predicate push down on that column, you can prune away a lot of files that way. Yeah, I don't have that much time left, so I just have a few more slides. This is example of a use case I had, like a little bit to build something a little beyond Iceberg using what Iceberg provided. So in our architecture, we had like a ingest pipeline of events flowing from like Kafka through Flink into Iceberg. And we wanted to just measure like the ingest pipeline, the performance of it in terms of data latency and data completeness. If you know, this is kind of usually kind of a hard problem to measure in ingest, but with Iceberg it was very easy. For data completeness, the trick here is just to make sure the source and target are bucketed by the same kind of event time definition, and then compare the size of both, right? And so in our data model, we just bucketed each event by the event time in Iceberg, which was our target. And then using the partitions table, just took a record count of each partition and then compared that to each event time corresponding bucket in the source to see data completeness, like how many events were dropped or made it or did not make it to Iceberg. Data latency. So this is this is measuring how long events take to make it into Iceberg. And this is actually very reminiscent of that first query that was quite hard, the last update time per partition. So if you remember over there, we were trying to find in each partition the maximum update time, the last commit time, right? So here we're doing almost the same thing, but instead of that, we finding the max difference between the commit time and then the event time when that event was created. But how do we know in the metadata tables what's the least event time of a file? Well, again, we have lower bounds for that column, so we can just take the max difference of that lower bound event time and then the commit time, which we get again by joining the snapshot table to get the data latency. So for each bucket, how long it takes from the events, the maximum time it takes for an event source to land into Iceberg. Yeah, just one more slide. Oops, one more. Yeah. So data quality, I think, is something can really benefit from metadata tables. Like, for example, I like to create alerts so we have a lot of statistics, again, for each data file for every columns. And like something interesting things are like, for example, we can graph how many non-values we have, not a number of values, which will indicate error. You can create alerts on that. Maybe no values if they exceed a threshold, maybe lower and upper bounds if they have something you don't expect. Is kind of interesting field for data quality. On that topic, we may even, so I think there's a lot more metadata tables coming in the future. One interesting direction the Iceberg community is heading, very exciting, is the Puffin files. I think it's introduced and being used already. These are going to track even more advanced statistics like data sketches, maybe possibly Bloom filters. And the point here is like, hopefully there'll be metadata tables on that, and we can, as users, query them to get interesting things as well, like maybe histograms or even distinct value counts for different columns. So I think I'll end here. I'll leave about some time for questions. But again, thanks everyone for attending this talk, and I hope you found it useful.